All right, so what you're going to be doing is coming up, we got one final Ferris wheel, but this time, instead of me giving you the period or telling you what the period is, you're going to have to figure it out from a video, what the period is of a particular Ferris wheel. All right, so what you're going to be seeing here. Okay. So you get on this Ferris wheel at the red cart. Okay. So on yours it just says red cart because it's black and white paper. So the red cart is down here at the bottom. Then what's going to happen is you're going to run this Ferris wheel for 3 minutes. And what you're going to do is you're going to come up with an equation that'll tell us or tell you how high the cart is at the end of that 3-minute ride. So in the future, after this runs for 3 minutes, how high above the ground is that red cart? Okay. Now, just the dimensions on this, so that you understand what they are. You're not told what the midline is. You're going to have to figure that out. You're told that from the ground up to the red cart is 9 feet. That's this right here. And you're told that the diameter of this Ferris wheel is 50 feet. So from those those values there, you're going to have to figure out what the highest point is, what the middle is, and what the lowest point is. Okay. All right. So that's sort of the scenario of the cart. Now here, where it says find the period of the red cart, the time it takes to complete one revolution by watching the Act 1 video. All right, so that is the video that is attached to your Google Classroom here. All right, so back. All right, so when the job is when that countdown clock is 0, you're going to predict before doing it where the cart's going to be. So I gave you the information of the heights, and then this is all the information you have for the period. Okay, so that's it. So you can see it didn't go all the way around. Okay, take it back a little bit. You're only getting a part of the revolution. Okay, so from that it went 2 minutes. It's 2 minutes 45 seconds. So it moved 15 seconds. All right, so if it moved 15 seconds, this is your position after 15 seconds. Okay, so this is your height after 15 seconds. So this is, we'll just say the position after 15 seconds. At 15 seconds. So you've got to figure out if it's there at 15 seconds, when is it going to be back to where it started? That's your period. Okay, but you're only given a partial information about it because the video only went to here and then stopped. It didn't go all the way around. All right, so you're going to have to figure out how would you get how long it would take from you to go from this position all the way around if all you know is that at 15 seconds you're here. So you can use that video and figure it out, or you can kind of use a little bit of logic here and just think, if it moved from here to here in 15 seconds, how long would it take maybe to get to there? Then you can figure out what these times are. That's your first time. This is time 0. So your height at 0 seconds is what, guys? 9. So at 0 seconds, my height is 9 feet. So I can put a dot right there. Now, I've got to figure out, you're going to be filling in the times for these. This was the initial time. Then where are you going to be at time 1? What's time 2, which would be up here? Okay, back here would be time 3. How many seconds is that? And then when you're back to where you started, okay, at time 4, you're going to be back at the same height. So you know this is going to be 9. So here's what you've got to fill in here, everything that I'm highlighting. Okay, so on this page here, you're going to have a value right here. Okay, you're going to have the radius of the Ferris wheel, the height of the axle. Okay, that would be right here in the middle. That's the midline. And then you're going to have each one of these boxes filled in. Okay, then you're going to do what's your amplitude, find your B value, determine the phase shift, and determine the vertical shift, and then you're going to write your equation. Okay. So when you do your table, you're then going to graph the table. Graph and draw a curve. So this isn't the curve. Your curve's going to look different. This is the regular sine curve. So remember, what we did with this was, once you draw yours, you're going to take this one that I'm highlighting in blue, and you're going to figure out how much do you have to slide it so that it matches the graph that you drew. The amount you have to slide it would be the same as its phase shift. So you're going to be plotting your other points up here. T1, T2, T3, time 4. All right. So then at the end of all this, you're going to have an equation that you're going to write right here. Okay. All right. Once you got that equation, you're going to go to Desmos and you're going to enter whatever that equation was. So you just open up a regular Desmos file and you're going to enter in the equation that you came up with, whatever it is. And you're going to get a graph that looks something like this. You are going to fill in then, what are these numbers? And then what are these numbers? Okay, and then finally, you're going to go back and answer, you're going to use the model that you drew to predict what's the height of the car at the end of 3 minutes. You're going to put your answer right here. Okay, then you're going to, wherever that point is on the graph, you're going to graph that point. Okay, so this answer is going to be on the graph. And when you graph it, wherever you are, put the coordinates. What are the coordinates of the point? Okay, when it's at 180 seconds. And then the final question is, how long would should the ride be so that the red car ends up where it started? So here's your start point. And we already know this is like 9 feet. Okay, at the end of 3 minutes, or not at the end of 3 minutes, but at the end of 3 minutes, you're not going to be back at 9 feet. What time would put you back at 9 feet? So you're going to end up at one of these valleys here. And what would the time in seconds be? Okay. And you'll answer that, and then you'll graph that one too. Okay, so here you're going to have your height. You're going to say height, and then fill in your height. How tall is the car at 180 seconds? And then you're going to graph the point. Then down here, you're going to say, how long should the ride be? And then you're going to graph that you're going to graph the point on the graph as well. Okay. So using this position at 15 seconds, figure out your 4 times, figure out what your period is, and then divide that by 4. And that's going to be your times that you put in here. These are going to be this is going to be your period divided by 4. So you could stop this earlier than 15 seconds and get a pretty good idea where your first time would be as well. Okay. Oops.
That's not fun.
Oh, sweet. Okay. All righty. Okay. All right. Good. I'll alter your grade. What? I just finished talking. Yeah, apparently, yeah. Well, good. I'm glad. Okay, so let's see. Okay, check your height. Check your mid height. This one. Okay. So these should be heights. That's 9, right? Okay, so at 10 seconds, where is it located? Okay, no, that 50 is this dimension.
Oh, I see what I did wrong. I thought 50 was.
No, oh, yeah, I could see how you'd think that. Hey, folks, that 50 right here, if you look up here, guys, 50 is not the midline. Okay? This 50 just is telling you that this height is 50. I could see how you might think 50 is the midline because it's right next to it. That was just a product of the drawing. The wheel is 50 feet in diameter. This is the diameter. The midline is not 50.
Was there a lot of questions for the midline? About 25.
No.
Oh.
Okay, so yeah, I shouldn't have put that 50 right next to that idea. Okay, so the diameter of the Ferris wheel is 50. Okay. So from here to here is 50 feet, but this is 9 feet above the ground. So that's 9 feet.
Oh, I see.
And then that's 59 feet. This is 9. Now you got to figure out what's halfway between it, and that is going to be midpoint.
Oh, yeah. Thank you.
Yeah, the drawing was kind of rushing when I made that drawing. Yeah. So yeah, the midline. So up to here is 9, and this would be 59. This is 9, and then the midline would be halfway between those two. Yes, they are. Very good. So the midline is not 50. The midline is not 25. It is not 25. So what did you get for the midline?
That's what I got from it.
Okay, so what's the vertical shift? Oh, you can't plot it. My graph isn't. Oh, rats. Guys, you won't have enough room to plot it. That's my bad. Rats. Should have made the graph longer. You could still answer these. You just won't be able to plot the graph. You won't be able to plot the point because I don't think there's enough room.